welcome to a confidence interval for population mean example. So our example, a study was run to determine the average household income in the Bay Area. It is known that the standard deviation in the household income is $35,000. A random sample of 100 households had an average income of $117,245. Find the 95% confidence interval. So first thing we want to do is just understand the problem. So we are trying to estimate the average household income in the Bay Area. So immediately we're trying to estimate. That tells us that we are doing a confidence interval. And then we have our keyword. We are looking at the average household income. So we are talking about the mean. We have just one population involved. So we know that we are doing a one population, mean, and interval. In addition to this, we have our population standard deviation. It's a known fact. So here's our population standard deviation of 35,000. So this is our sigma, is 35,000. We take a random sample of the households, and it has 100 households. So N is 100. We do have a random sample. And it's presumably drawn from the entire population. Furthermore, in that sample, we have an average of 117,245. So X bar is 117,245. And then we know that we are doing a 95% confidence interval. From here, we move in. So we are doing an interval for the population mean. Any type of inference we do whatsoever, we need our good sampling technique. So again, we have random, and that it draws from the entire population. And then for our normality conditions, normality of the X bar distribution. We just need to either have normality of the population data, which we were not told, or we simply need our sample size to be 30 or larger. So N is 30 or larger. That's definitely true. We have random, it was drawn from the entire population. So what we have is the study was well run. And the conditions for normality were met. Okay, so the study was well run, and the conditions were met for normality of the X-bar distribution. So we can find the confidence interval. Our next job again is to understand the sampling distribution. So in this case, we are talking about the X-bar distribution. We just saw in step 2 that we have a normal distribution. The center is what we are trying to estimate. So this is what we wish to estimate. And then the spread, we have the sigma sub X bar is simply equal to sigma divided by the square root of n. So in this case, our sigma was 35,000. And then we are dividing by the square root of 100, if I remember correctly. And so this winds up being 3,500. From here, we find our interval. So we have our point estimate. The point estimate is our sample statistic. In this case, it was X bar is 117,245. Our margin of error, we are doing 95% confidence. So we use 1.96 since we are 95% confidence times our sigma sub X bar. So we have 1.96 times 3,500. And that winds up being 6,860. And I will be back. Next up, we need to find our interval. So our interval, we take our point estimate of X bar. We go up by our margin of error and down by our margin of error. So in this case, we start off with our 117,245. We add 6,860 going to the right. We subtract 6,860 going to the left. And that winds up giving us 110,385 on the left, and on the right, 124,105. So our confidence interval we are looking our interval is from 110,385 to 124,105. So our conclusion, we have I am 95% confident that the average income of Bay Area households falls between $110,385 and $124,105. Again, 95% was our confidence level. Whoops. The average income of Bay Area households was what we were trying to estimate. The $110,385 was the left or lower end of our interval. The $124,105 was the upper end of our interval. So this is our confidence interval. Just one quick comment. When we were doing this confidence interval, this problem, we were given the statement that it is known that the standard deviation was $35,000. It is fairly rare for us to know the population standard deviation and not know the population mean. In fact, we need the population mean in order to calculate the population standard deviation. Sometimes they will use a known standard deviation from a previous study, but in reality, this is a fairly rare situation. Usually we are forced to work with a sample standard deviation. So again, just a quick comment. It is rare for us to know the population standard deviation. In actual studies, usually we only have the sample standard deviation. So in the next videos, we'll talk about how we can modify our confidence intervals to account for only having the sample standard deviation. So that's confidence interval for the population mean. For now, when we know the population standard deviation in advance.